So today we're in conversation with Zinhle Buthelezi. Zinhle, here we are at iThemba Labs. But tell me, when you were younger, what's this dream?
When I was younger, the dream was actually science, but it wasn't clear exactly which science route I was wanting to take. So it took me a long time, but I knew that I wanted something to explain how things work, what life is about. I used to look outside and look at the sky, look at the things we can see and wonder, why can we see these things and other things we are told they exist, but we don't see them? So that was the trigger, really.
I pick up that you're driven by curiosity, the need to answer questions. So what exactly is it that you do at iThemba Labs?
I am what you call a research scientist. I hold a PhD in nuclear physics. However, over the years, I have gone beyond just low energy nuclear physics. I do research in high energy physics, which is utilizing facilities that are in Europe, in Geneva and CERN.
So if you say high energy, is it just high energy because we can go higher, or do we need high energy for something very specific?
It's actually both. So we need high energy because we want to look at smaller composites of a nucleus, which we talk about a lot as nuclear physicists, and we're interested in your nucleus. But there are also much smaller composites inside the nucleus, like your proton and neutrons, but even smaller inside the proton and neutrons, what we call quarks and the gluons that hold them together, which brings us to the fact that you cannot isolate these particles from a nucleus or the nucleus from the atom. This is what we want to study and understand how this influence life, the universe, when it started, and everything really that we know.
So you're talking about things that are very, very, very small.
Yes.
So what gets you up in the morning? I mean, you can't even see them, and yet you are excited to get to the office.
It's exactly that. Is it because you want to see something that you can't see with your naked eye? So you need very big, nice, exciting tools in order to do that. The idea of using those tools to see if you can see what you want is really what drives me every day. Even when the day is really bad and boring, think, today maybe I try this, maybe I try this instrument, maybe I try this code. So there are many facets to it. That's what drives me. All the facets put together and the people that you get to talk to while doing that is what drives me every day.
And I get the sense that things don't always go your way. So what do you do when things go horribly wrong?
That happens quite often actually. In research in general, there are days where everything is like, but then you think, okay, maybe today I will read a paper. That usually does trigger your interest and you get motivated, or you talk to people during your tea time or your lunch time, or you take a walk. When you are walking, you tend to think a lot more and you become clearer in your thinking. So this is what we do when we hit that plateau. It brings you to something that you didn't realize you were missing. So that's what I do whenever I hit that plateau.
During COVID, we became aware of the impact of science and the value that science brings to everyday people and to everyday lives.
Yes.
So how would you position the impact of what you do, and why do you do what you do?
It's a good question. People, they think about fundamental science and they think about all these big sciences, a lot of money. But what's important here is that the outcomes and the things that you didn't start off with are the spin-offs that you get from big science. We fumble upon some things that we didn't think about, things that are applicable to the society, and things that young people didn't think about, especially the tools that we are using. They can have applications beyond just research. So that means we bring a lot of technology, the revolution of technology and frontiers to the social atmosphere, and mostly also influencing industry, because with that, industry gets more motivated to build tools that we need in order to do what we want to do. For example, the web was born in this way, and talking about silicon chips and the application of that, television, all of these things are really things that we fumbled upon while we're trying to do normal, general, fundamental research. So the spin-offs are the things that we think we're bringing to society. Therefore, research is really an integral part of everyday life, in any life, if we want to move forward and progress.
So I pick up in your voice and looking at your face the energy and the excitement, but I'm sure that there are many young people who might sit there and think, well, this thing is not for me, it's too tough. Any final word that you want to share with them?
Self-belief is very, very important. You can't let people tell you what you can and cannot do. Now that we know we can do whatever we set our minds to do, just pursue what you feel you want to pursue. But more than that, also try to talk to other people if you can, find information as much as you can, and try to get the support that you think you need in order to reach your goal. You cannot say, I cannot do that, it's too difficult. You have to try. You have to find yourself doing it, and then if it doesn't work, then you find something else, but never give up on yourself.
So there we have it, talking to Zinhle Buthelezi, a high energy physicist who doesn't just use the high energy to see small things, but who gets high energy from doing what she loves. Thanks for spending time with us. Until we chat again.
Thank you. Cheers.